This presentation for Statistical Methods 1 is on estimating population means with sigma known. Definition. A point estimate is a single number estimate of a population parameter. An unbiased estimate is a point estimate that does not consistently under or overestimate the population parameter. The mean GPA for 112 residents of the local apartment complex is 1.7. What is the point estimate for that mean GPA for all residents of the local apartment complex? So 1.7 is the point estimate, so it's just going to be the 1.7. Example number 2. At the local college, a study found that students earned an average of 14.2 credit hours per semester. A sample of 126 students was taken. What is the best point estimate for the average number of credit hours per semester for all students at the local college? So our point estimate is 14.2. Definition. An interval estimate is a range of possible values for a population parameter. The level of confidence, denoted by C, is the percentage of all possible samples of a given size that will produce interval estimates that contain the actual parameter. Confidence interval is an interval estimate associated with a certain level of confidence. The margin of error, or maximum error of estimate E, is the largest possible distance from the point estimate that a confidence interval will cover. Formula: confidence interval for a population mean. X bar minus Z sub alpha over 2 times sigma divided by the square root of n is less than or equal to the mean is less than or equal to X bar plus Z sub alpha over 2 times sigma divided by the square root of n. Or X bar minus E. So E is equal to that right here. Z sub alpha times sigma divided by the square root of n, where E is the margin of error, X bar is the sample mean, Z sub alpha over 2 is the critical value for the level of confidence, that's your C, sigma is the population standard deviation, n is the sample size. For example number 3, we're going to use the tables and hogs. Ernest desires to know the mean consumption of milk per week among males over the age 26 for his dairy farm. He asked 2,172 males over the age 26, and the mean milk consumption was 2.4 liters. Assume that the population standard deviation is known to be 1.3 liters. Construct a 98% confidence interval for this research. So we have that our X bar is equal to the mean, which is 2.4. So our X bar is 2.4. Our N is 2,172. Our sigma is 1.3. We're given all of these in the problem. So the only thing we need to find is our Z sub alpha over 2. To do that, we can use the table here. So to use this table, we would go to the critical values of C table, and this was under the, which one was it? Statistical tables. So you go to level of confidence C, and you find the 98%, and your Z sub alpha over 2 is the 2.33. So our Z sub alpha over 2 is 2.33. So our formula that we're going to use, let's add another slide here because I think we need a little bit more room, is X bar minus the Z sub alpha over 2 times the standard deviation divided by the square root of n is less than the mean is less than X bar plus Z sub alpha over 2 times the square root divided by this times the standard deviation divided by the square root of n. So we have 2.4 minus our 2.33 times 1.3 divided by the square root of 2,172 is less than the mean is less than 2.4 plus 2.33 times 1.3 divided by the square root of 2,172. So let's do that in our calculator. 2.4 minus 2.33 times, I'm going to put this part in parentheses, but I don't think you need to. And we're going to do the 1.3 divided by the square root of 2,172. Close parentheses. Or maybe we should get out of the... So we get 2.335, and it asks us to round the answer to one decimal place. So it's 2.3 for our lower value. Is less than the mean is less than. And then we're going to do it again to find the upper value. All we're doing is changing that minus to a plus, so you can go second enter, and then just arrow back instead of having to type it all over again, but you can definitely type it all over again. Change that to a plus, and we end up with 2.46, which rounds to 2.5. We were asked to find the confidence interval for this research, and it should also say to round your answer to one decimal place. I will fix that in the notes. Example number 4. The Waterworks Commission needs to know the mean household usage of water by residents of a small town in gallons per day. Assume the population standard deviation is 2.3 gallons, so our sigma is 2.3. Edwin, whom works for the commission, found the water usage per day to be 16.7 gallons per day. So our mean is our 16.7. And for the 788 families he surveyed, so our N is 784 families he surveyed. Construct a 95% confidence interval around to one decimal place. So another way to do it is to use the tables in the formula packet that is posted in Moodle. And this table is right after chapter 12. So this is the same table, and we're looking for 95%. So here our z sub alpha over 2 for 95% is 1.96. So our z sub alpha over 2 is 1.96. So let's do this formula again. So we have our x bar, which is 16.7. Did I use mu? It's supposed to be x bar. I'm sorry. I should say x bar. Because it's our sample mean. So 16.7 minus our 1.96 times the 2.3 divided by the square root of 784 is less than the mean is less than the 16.7 plus 1.96 times the 2.3 divided by the square root of 784. So let's put that in our calculator. 16.7 minus 1.96 times 2.3 divided by the square root of 784. See, without the parentheses, it still gives you the correct answer. So this is 16.53, which is 16.5. So our lower interval number is 16.5. And then to find our upper interval number, we just add. So second enter to get what you got in there if you have your graphing calculator. And then plus. 16.86 rounds to 16.9. 16.9. Okay, so that's our interval for this one. We round to one decimal place. Example number 5. Another thing I would like to do here before we move on is I want to interpret what this means. So let's interpret this one. on the project you're going to be asked to interpret. So to interpret this one, we were asked to find a 95% confidence interval. So we would say we are 95% confident the residents use between 16.5 let's fix it up, and 16.9 gallons of water per day. And you can phrase it differently. You can say we're 95% confident the residents of the small town or something like that. Just as long as you restate the problem or the question and state that you're 95% confident or whatever the percentage was for this value. So for example, number 5, the mean number of hours of part-time work per week for a sample of 108 teenagers is 23. If the margin of error for the population mean is 1.6, construct a 99% confidence interval for the mean number of hours of part-time work for the week. Round to the nearest tenth, which is 1 decimal place. So you should know your place values, so I wanted to put that in there here. And I'm missing my L and my and the word decimal. So for this one, they've already given us that margin of error. So we have our X bar that they've given us, which is the 23. So the formula readings for this one is just X bar minus E is less than the mu is less than X bar plus E, because they've already given us the E. And our E here is, it says that if the margin of error for the population mean is 1.6. So this is a simpler problem where we just need to subtract and add. So we're going to do 23 minus 1.6 is less than the mean is less than 23 plus 1.6. So we take 23 and we minus 1.6. So we get 21.4 is less than the mean is less than, and then 23 plus 1.6 is 24.6. To interpret this, we would say we are 99% confident the number of part-time hours per week for teenagers is between 21.4 and 24.6. So it's a good idea to know how to interpret your results. That's the whole reason why we're doing it. For example number 6, there's a way that the calculator can do many of this for you. We're going to do this one using the calculator. So a toy manufacturer wants to know how many new toys children purchase each year. A sample of 458 children, so our N is 458, found a sample mean of 6.1, so our X bar is 6.1. Assume the population standard deviation is 1.2, that's our sigma, and construct a 95% confidence interval. So that's going to be 0.95. So 95% is equal to 0.95. So when we were looking it up, we were looking up the decimal form. Round to the nearest tenths, and that's 1 decimal place. So we're going to do this one in the calculator because the calculator does do this for you. So we're going to go to, we're just going to hit the stat button, arrow over to the word test, and for my calculator it's number 7. And so I've already got these in here. So our sigma is 1.2, Our x bar is 6.1. You can just type those in. Our n is 458, and our C level needs to be in the form of a decimal, which is 0.95. And then you click calculate. And we get 5.9901 to 6.2099. So that rounds, the 5.99 rounds to 6.0. So we had 5.99. We have to round to the nearest one decimal place. So this 9 bumps that 9 up. You add 1 there, becomes a 0 and a 1 here. So you get 6.0 as less than the mean, as less than, and the 6.2099 rounds to 6.2. And so we would say we are 95% confident that children buy between 6 and 6.2 toys. But I mean, for this one, because you're not going to really buy part of a toy, you could just interpret it and say children buy about 6 toys. Minimum sample size for estimating population mean. If a researcher or if anybody wants to conduct a study on something that interests them, that has been studied before, they need to be sure they have a sample size large enough that it will be normally distributed. We always want to use a large enough sample size, but we can find the minimum sample size with following this formula. So I know that we're supposed to use at least 30, but more is always better to make sure that it is distributed normally. So the formula we're going to use for the sample, for the mean, is n is equal to z sub alpha over 2 times sigma divided by e. This here on the bottom should be an e. Oh, I have to fix that one. That should be the capital E. That's the error. Where sigma sub alpha over 2 is the critical value for the level of confidence, sigma is the population standard deviation, E is the desired maximum margin of error. Example number 7. Antoinetta is an economist who wants to estimate the mean per capita income in thousands of dollars for a major city in California. She believes that the mean income is 24.4 and the variance is 139.24. How large a sample size would she need to use in order to estimate the mean per capita income at the 98% level of confidence with an error of at most 53 cents? Round up to the next integer. We always round up for these. We always go up to the next integer. Even if it's 27.000001, it's going to be 28. So for this one, we do not need the mean. So they're going to give you that extra information, but you don't need it. And they've given us that the variance is 139.24. So our sigma squared is 139.24. So we need to find the standard deviation, which is the square root of 139.24. So in our calculator, when we do the square root of 139.24, we get, that did not work, 139.24. We get 11.8. So our sigma is 11.8. We have our z sub alpha over 2, and we look that up in our table or any way we want to look it up. We get the 2.33 for the 98%. And then the error says it needs to be at most 0.53. So our E is 0.53. So N is equal to 2.33 times 11.8 divided by 0.53. Something a lot of people forget to do is they forget to square it. Do not forget to square it. So we're going to do that just like that in a calculator. Open parentheses. 2.33 divided by, 2.33 times 11.8 divided by 0.53, close parentheses, and then make sure that you hit the squared button. So we have 2,691.0. It doesn't matter what it is. It's going to be 2,692. Always go up to the next number. So our n is equal to 2,692. You do not round correctly with this. You always go up. That's the only time you ever, well, one of the only times you do not round correctly. Example number 8. A soft drink manufacturer wishes to know how many soft drinks teenagers drink each week. They want to construct a 99% confidence interval with an error of no more than 0.06. A consultant found a previous study with a mean of 3.7 and a standard deviation of 1. What is the minimum sample size needed? Round up. I just put the round up in there, but I know it doesn't say that on most of the questions. So we're using n is equal to our z sub alpha over 2 times sigma divided by e, and then squaring that. So for the 99%, it's 2.33. It's 98. Nope, I'm on the wrong question. For the 99%, it's 2.575 times the 1 divided by our 0.06, and then squaring that. So in our calculator, we have open parentheses, because we have to square the whole thing, we need to put it in parentheses. 2.575 times 1, and it's not necessary that you put the multiplication times 1 in this case, 0.06, close parentheses squared. So we get 1,841.8, it's 1,842. So n is equal to 1,842. For example number 9, Robert wishes to know the mean number of words third graders can read per minute. He wants to ensure that the estimate has an error of at most, so our E is 0.22, of at most 0.22 words per minute. A previous study found a mean of 23.9 words per minute and a variance of 31.36. So sigma squared is 31.36. That's our variance. What is the minimum number of third graders to include in this study to be 98% confident? So our 98% confident gives us a 2.33 for our z sub alpha over 2. We need to find the standard deviation, so we're going to be doing the square root of 31.36. When we do that, we find 5.6. So n is equal to the z sub alpha over 2, which is 2.33, times the standard deviation, sigma, which is 5.6, divided by the error, which is 0.22, and then we square that. So we go, open parentheses, 2.33. You have to use the parentheses here, otherwise your calculator is just going to square the very last number, times 5.6 divided by 0.22, close parentheses squared. And we end up with 3,517.5, which is 3,518. Do not round correctly for these.